All right, welcome back. Today, we're moving past just talking to our AI. We're going to dive into the world of action. We're going to figure out how to give our AI agents a reliable set of hands so they can perform real-world tasks, not just accurately, but safely too. Let's get right into it. Okay, so to get us started, a super simple question. What's 1492 divided by 3? Now, you and I know a calculator spits out the answer instantly, but what do you think happens when we ask a large language model the very same question? Well, you might get something kind of like this. It's close, sure, but it's not exact. The model is trying to be helpful, rounding down to make things simple. But in doing that, it completely misses the precision we absolutely need for so many tasks. And that right there, that tiny little error, that's the exact problem we're here to solve today.
This really gets to the heart of the matter. LLMs are kind of like a genius with some very specific, very predictable blind spots. They are incredible masters of language, of reasoning, but when you ask them for a precise, repeatable action, they can be surprisingly unreliable. So why do we even need these tools in the first place? Well, it's because LLMs are brilliant at understanding what you're asking for, but they're just not built for things like exact math or looking up specific data. The solution is to let the model do what it does best, figure out your intent, and then delegate the actual work to specialized code that you write and you trust. And look, this isn't about giving the model the keys to the kingdom. It's about giving it a very specific, approved set of actions it can perform reliably every single time. Okay, so how do we actually give our AI these tools? It all starts with teaching the model what its tools are and exactly how to use them. It all comes down to a blueprint. Let's check it out. The secret sauce here is something called a tool schema. Seriously, just think of it like an instruction manual that you hand over to the LLM for each and every tool you create. It tells the model everything it needs to know to call your code successfully. And what's really cool is how simple this blueprint is. It's just 3 parts. First up, the name. Gotta call it something, right? It's the unique ID. Second, and this is absolutely crucial, the description. This is you explaining in plain English what the tool does so the model knows when to use it. And third, the parameters. This just defines the specific ingredients the tool needs to do its job. It's a really simple but incredibly powerful system. Okay, so we've got the blueprint for the tool itself. But how does the actual back and forth between the model and our code work? This is where the safe loop pattern comes into play. It's basically the engine room that keeps this whole thing running smoothly and, more importantly, safely. So let's walk through just one turn of this loop step by step. First, the model decides it needs a tool and makes a request. Your code then adds that request to the conversation history. Then, and this is so important, you execute the tool, but only if it's on your approved allow list. After you get the result, you add that back into the history, and then you call the model one last time. This gives it all the context, all the new information it needs to give you, the user, a really helpful final answer. This loop ensures you are always in control. All right, building these tools is awesome. It's a total game changer, but you gotta be careful. There are a few common traps, these landmines that can really mess things up if you're not looking out for them. So let's cover the 4 most dangerous ones you need to avoid. Landmine number 1, and this is probably the most dangerous, is unrestricted access. If you don't have an allow list, you're basically letting the model try to call any function it can dream up. That could be a function that doesn't exist, or way worse, one you never intended it to use. The bottom line? Always validate the model's request against that list of approved tools. No excuses. Okay, landmine number 2. This one is sneaky, and it trips up so many people. The arguments the model sends for your tool, they usually arrive as a JSON string of text, not as a data object your code can immediately use. If your code forgets to do that one simple parsing step, it's just going to crash. So remember, parse that string before you use it. All right, our third landmine is information overload. Imagine your tool goes out and fetches a massive report, thousands of lines of text. If you just dump all of that back to the model, you're going to blow right past its context window and get an error. The fix is easy, though. Just shorten the output. Maybe summarize it, or just grab the most important part before you send it back. And last but not least, landmine number 4, configuration chaos. This is a total classic, a real which came first, the chicken or the egg kind of problem. If your tools need things like API keys from a config file, you have to load that configuration before you import your tool's code. Get that order wrong, and your tools won't start out correctly. Okay, You've got the theory, you know the pattern, and you know what landmines to avoid. So there's only one thing left to do, right? Let's get our hands dirty and actually build something. So here's your challenge, and it's a great first step. Can you build a simple tool that lets the model convert Celsius to Fahrenheit? It's basically the hello world for AI tools, and it uses everything we just talked about. So what's the game plan? First, you're going to add a new tool schema for a function. Let's call it C to F. Then, just ask the model a simple question, like convert 25 degrees C to Fahrenheit. And what you're looking for, the sign of success, is that your code actually calls your new tool and that the model just gives you back the clean, correct number. No fluff, no extra check, just the answer. And just like that, once you've done that, you've given your AI its first real tool, its first set of hands. You've unlocked this whole new world of what's possible. So the real question is, what are you going to teach it to build next?